This video is going to go over different mathematical operations and statistical tools that you can use with raster datasets. You can do a variety of different mathematical operations in raster datasets, including basic arithmetic, algebra, trigonometry, among others. There are three main types of statistical operations that you can perform on raster datasets, including cell, focal, and zonal statistics. They are differentiated by the cell and cell groups that are involved in the calculations. This is also how you will calculate any different mathematical formulas, so I'm not going to include that separately. Just think about doing different math operations within these different statistical operations. Cell statistics calculate values from multiple raster datasets for each individual cell. It can calculate the mean, median, mode, min, max, minority, or the value that occurs the least, the range, standard deviation, sum, and the number of unique values. In the image on the slide, there are three raster datasets being added together. And in this particular example, it is excluding any null values. So the null values are the gray areas that don't have any value. The second cell has a value of 3, which is right here. I'm not including this null value because there's a null value here. So the second value has a value of 3 because it's adding this value, and this value all together. So if there is any null value, it is not going to be included. So if you were to do this manually, which I don't plan on having you do, but what I would do to most easily get around this is to get rid of all of the locations where there are any null values, because you don't have to add any of those together. Focal statistics use neighborhood operations to calculate values based on the cells that surround each target cell, also known as the neighborhood. The neighborhood size and dimensions are determined by the users and are the same for each cell. However, it uses a moving window where the cells that are included change based on the target cell location. It can include the mean, median, mode, max, min, minority, percentile, range, standard deviation, sum, and the number of unique values. In the example on the slide, the output raster is calculated as the sum of the neighborhood. The neighborhood is the cells that are boxed in the yellow square on the right, and the target cell is the highlighted cell on the right. So when you add 3, 2, 3, 5, 4, 2, 1, and 4 together, you get a total of 24. Zonal statistics calculate cell values based on zones that are defined in a different data set. It can calculate the mean, median, min, max, minority, percentile, range, standard deviation, sum, and the number of unique values. In the image on the slide, the first raster is the zonal data set, and the second are the values that are going to be included. It's calculating the zonal sum for each range. So here there are two different areas that have, that are part of zone 1. So zone 1 is here and here, which is also here and here. So we're going to add all of these values together, which is 5. So then that's why each of these in the green is 5. Then you would calculate a different value for zone 0. So zone 0 is here and here, or here and here. So then the sum of those areas is 3. Oops. Sorry, I'm still getting used to this pen. Then you would do the same for the areas that have in zones 2 and zones 4. All right. So classification and reclassification allows you to change the input cell values to different or alternative values. This is usually done to replace any values based on new information. You can group certain values together, reclassify the values to a common scale, replace null values with an actual value, or make certain values null. It can be done to individual values within a range of values, or sliced by areas of equal interval, equal area, or natural breaks. In the image on the slide, the raster is being reclassified by individual number. So the values that were once 1 are now 5, the values that were originally 2 are now 5, and the values that were originally 3 are now 7, etc., etc. You may want to use this tool if you have a land cover dataset that has different levels of urbanization, water features, and vegetation, but all you really want to know about is the differences in vegetation. You could reclassify each of the different levels of urbanization into one urbanized category, and then change all of the water features like lakes, rivers, and ponds into a single water category, and then leave the different vegetation types alone. Or you could combine all of the urban and water features into one category and set it to null because you want to completely ignore it. There are an infinite number of ways you can use this tool. It all depends on the purpose of your analysis.